Welcome guys once again to the best math channel in the world. So I'm busy made it easy channel. The only channel is fierce, and the only channel will make mathematics fun. So if you follow this channel, the fear of mathematics will be a thing of the past. We did the finding the approximate values in logarithm in my previous videos, and today we are moving on to division of sets. Logarithm, how we can divide logarithm. So, and we know how we can divide logarithm if we have something like log am minus log an. The law says that if they are having a common log, we have to what? Divide them. And we are going to stress more on this. And we are going to solve more questions on this one. In the same way, if we are to have log 8 minus log 2, and we are asked to simplify, it doesn't have any base, but they have a common base. What's the common base? 10. But in my previous video, I explained that a log without a base is having base 10. Yes, a log without a base is having base 10. So this one, we have log 8 divided by 2. And log 8 on 2 divided 1 divided 4. So we have log the base 4, for which if we are to simplify, we have to find the approximate value. So which will give us 0.6021 if the question asks us to simplify. So this is the idea about how to divide any given logarithm. Most of them will be given the division, but most of them will be given in the subtraction form. And when they are dividing, you apply the division rule of logarithm and you solve it. Yes, and you solve it. We are not going to waste much time here. We are going to have our first question on how to apply more of the division principle in logarithm. So let's take the first question. So as the question is posted on the screen, we have to find log 125 all over log 25 to divide this log. So what you have to check is, can we express this one as common powers, this and the top one as common powers? The answer is yes. So the top one, we can have log to the base, log 5 power 3. Yes, 5 raised to the power 3 will give you 125, and the down one to give us log 5 raised to the power 2. And as we all know, the power will come here, so log to the base 5, then we have 2 log to the base 5. We've gotten a common log for this. So now when we have a common log for it, what do we do? So what we do is we cancel out the log, they will divide, and we'll have our final answer as 3 on 2. So this is how we divide this question. You express them as common powers, then you apply the logarithm principle of the powers to solve. Yes, so you follow closely step by step and you solve. So the final answer is 3 on 2. So to simplify, log 125 divided by log 25, the answer is 3 on 2. And this is why this answer pops up when you press this using the calculator. We are taking the next question. So we have to simplify log 27 over log to the base 6 minus log to the base 2. Yes, the log 27 is dividing this. So we have log 27, then the down one, they are subtracting. So they are going to divide here 6 on 2. So log 27, log 6 on 2. 2 can divide here, 1 divide here, 3. So now we have log 27 on log 3. Yes, we are continuing. So log 27, then log 3. They have common base. Do you agree? Yes. Now 10. So let's express this as power of 3. 27 will give us 3 raised to the power 3, 3, 3, 9, 9, 3, 27, all over log raised to the power, all over log 3. So we have 3 log 3 divided by log 3. Yes, divided by log 3. So we can divide log 3 by log 3, then we get our simple answer as 3. Division of log. When we are subtracting with a common base. Yes, so a log without a base is log 10. So we divide the denominator, then the denominator, we express the numerator as power of 3. Yes, you check. So if you can express them as power to get a common one, then you express them. So that's why when you press this on the calculator, it pops up as 3. So this is a step-by-step calculation to that. So we are going to take another question, which is a past question also on the logarithm. So we have to simplify log a raised to the power 3 minus log a all over log a. So we have to simplify this. And when you look at the top one, it is subtracting. So we have to divide. Yes, we have to divide. So if you look at it, it is divided. So we have log, then we have a raised to the power. We are going to have a raised to the power 3 over a all over excuse me, all over log a. Yes, all over log a. I'm going to expand the top one. So we are going to have log, then we have a times a times a all over a, then all over this log a. I don't like jumping steps when I'm teaching because I want you to follow closely. So now this a will cancel this a. Now we have log to the power, now a times a will give you a squared all over log a. Yes, a squared all over log a. We have to simplify, and this is not the final answer. And we all know that we have log a squared all over log a, and the top one is going to give us, the power will come at the back of the log, giving log 2a all over log a. Now we have arrived at they having a common log. Now what do? We cancel them out by dividing to get 2. Yes, so now our final answer has also given us 2. Yes, to simplify this, the final answer has given us 2. So a raised to the power 3 minus log a, then I expanded it here. This and this were divided all over log a. So I expanded, then I cancel out. So all over log a times a give log a squared over a. Then I wrote it back, then I brought it 2, then I expressed it. So the final answer for this is also log 2. The final answer for it is 2. So let's take another question on this. So with the question posted on the screen, there's a given that log p is x and log q is y, which we express log p q on 100. This is what the question has given us. They've given us log p as, and what we have to understand is that now log p equal to x is the same as log to the base 10p is equal to x. I've introduced it because a log without a base is power 10. So now we have p is equal to 10 power x. I've expressed log p is equal to 10 power x. Now let me come to log q. So log Q, which is also y, will give me log Q, log 10Q is equal to y. Yes, for which that one to give me Q is equal to 10 raised to the power y. Now follow closely. Log P is x, log Q is y. So I have to express log this in terms of P or in terms of x and y. I have to express this in terms of x and y. And follow closely. Now P, I've gotten this. With Q, I've also gotten this. But the question itself says that we have to evaluate PQ. Now the PQ means P times Q. And now P is 10 raised to the power x times Q, 10 raised to the power y. So the bases are the same, they are multiplying. What do you do? I'll add the top numbers. Now I'm going to have 10x plus y. So now I've expressed the top one. So now I'm going to write this all over the 100 they've given me. Yes, I'm going to write it all over the 100 they've given me. So now I've gotten log 10x plus y all over 100. Log 10 x plus y, and you know how I arrive at this side. I'm going to express all of them in log. So this one will give me log 10x all over, this one give me 10 raised to the power 2. Yes, sorry, plus y. Now I'll have log 10x plus y all over. Now the 10 raised to the power 2 give me log 10 raised to the power 2. Yes, log 10 raised to the power 2. Now follow closely step by step. Now this, the top one, will now give me x plus y all over. This one will also give me 2. You have simple log, or they have a common log. Yes, they have a common log. So I have x plus y log 10 minus 2 log 10. So log 10 will cross out. Log 10 is going to cross out. So now I'm going to have x plus y minus 2. Yeah, the division tend to subtraction. So x plus y minus 2 as our final answer. So therefore, log PQ all over 100, to express this in terms of x and y, will be equal to x plus y minus 2. So you follow closely how I express this and arrive here, how I express the Q2 and I arrive here, then I put them together, then over 100, then I express this one as power of 10, then I wrote the logs x plus y, this coming here and the 2 coming here. So they are subtracting, and when you're dividing, we subtract. Yes, and when they are subtracting 2 and want to solve, we divide to solve them as the inverse. So this is how we express the P and Q in terms of x and y. So we are going to take our last question on this part. So in this question, as posted on the screen, we have to solve log 2 8 plus log 2 2 in square, or the square root of 2 all over log 2 1 on root 2 minus log 2 root 2 as well. Now we are going to take our time. I'm going to take my time to solve them one after the other to arrive at the answer. Now when you look at this log 2, 8, I can express the 8 in terms of 2's. So if you remember, so I can have log 2, 8 is equal to, let me use x. Yes, so I can have 8 is equal to 2 raised to the power x. So I can express this one as 2 raised to the power 3, then 2 raised to the power x. Now I'll have x is equal to 3. That's it for this one. Yes. Now when you look at this, this can also be expressed as log 2 root 2, which is the same as 2 root 2 times 2 raised to the power half. The square root of a number is the same as power half of the number. So I'll have 2, 1 times 2, 1 on 2. Yes, 1 on 2. Follow closely. It doesn't have a power, so we introduce the power 1. Now I'm going to add their powers, which is 1. So let me add it. So I'll have 1 on 1 plus 1 on 2. So the LCM will be 2. 2 divide here. 1 will divide here 2. 2, 1, 2. 2 divided here 1 times 1, 1. So I have 3 on 2. 3 on 2, which is for this one. Yes, which is for this one. So follow closely. This is for this one too. And this one, I've solved it as 3 here. Now let's break this 1, 2 down. So log 2, 1 on root 2 is the same as log root 2, 1 on 2 half. So I'll have log root 2, this the inverse form, so 2. Now log to the base of itself is 1. So 1 times, so this log 2 will be 1, then times this one. So this one will straight to give me negative 1 on 2. So now I'm breaking down this one, this and this. Now it has left with this, for which is also very simple for us to solve. Now we have log 2 root 2, for which that one also give me log 2. Then we have 2 raised to the power half, for which can also be simplified as this one. So 2, 2, 1. So this one will also give me 1 on 2. Now I've broken down all these ones. Now I'm going to fix them inside the expression and solve. So the log 2, 8, I got 3. Now plus log 2 root 2. That one too, what did I get? I got 3 on 2. All over. Now log 2, 1 on root 2. That's what gave me the negative 1 on 2 minus log 2 root 2, which also gave me the 1 on 2. So the top one, I'm going to use addition of fraction to solve. Yes, if you still find problem in adding and subtracting fraction, there's a video on board mass and ped mass. You can go and watch them. So I'm going to add them separately. So 3 will be on 1. Every whole number is over 1. Now I have 3 on 2. Now the LCM will be 2. 1 will divide to 2. 2, 3, 6. 2 divided itself 1 times 3. 3. Now I have 9 on 2. So the top one has given me 9 on 2. Yes, 9 on 2. Now let's come to the down one. I have negative 1 on 2 minus 1 on 2. Here the LCM is going to be 2. 2 divided itself 1. 1 times negative 1 negative 1 minus 2 divided itself 1. 1 times 1 also give me 1. So this one also give me negative 2 on 2. Negative 2 on 2. You are owing 1, you went to borrow 1, negative 2 on 2. So the top expression has given me 9 on 2. Then the down has been negative 2 on 2. So now we have 9 on 2 divided or let me write it like this, negative 2 on 2, which can also be written as 9 on 2 divided by negative 2 on 2. Division of fraction will turn to multiplication. Then the denominator will become numerator. So 9 on 2, we have times negative 2, yes, on 2. Well, negative is affecting all of them. Yeah, negative is affecting all of them. So anywhere I write it, yes, if the negative is affecting all of them. So, or despite is here, is affecting all of them. So now the LCM here too. No, subtraction of multiplication of fraction, we don't find the LCM. So we can cross divide here, 1, here 1. So 9 times negative 1 will be negative 9, then 1 times will be over 2. Now we have to simplify. So 2 can divide, the answer, if you expect a negative answer, 2 can divide 9. How many times? 4 times. Then remember what? 1 all on 2. So this is the final answer to this. So it seems to be complex. I took my time. I expressed this one as 3. And I've told you, if you can express the whole number as the power of the base, that one, you solve it by equating it to a letter. Then this one, you've done that. The law of logarithm. We did it. 2 times any number in root is the same as the number raised to the power half. I added their top. A number without a power has power 1. I introduced it. I added the fractions here. Then I got 3 on 2. Then I expressed this one as this, the inverse. I got negative 1 on 2. Then I expressed this one 2. Then I got 1 on 2. I added the fractions on top. Then I came to add. Then I got my final answer. Then I divided. Then I arrived at the negative 4. 1 on 2. So this is how division of fraction is solved, and these are past questions that I selected to make you understand. So if today is your first time watching this channel, don't forget to subscribe and recommend to all students at all levels that the best math channel in Ghana is here, and it is here for all of us to have a benefit or to overcome our fear of mathematics. So this is a Young Busy Made It Easy channel once again, and watch out for exponential equation or logarithm involving equations and also involving the change of base. So until we meet again, we say goodbye for now.